Hi everybody, this is Gigi from Kauai Community College. In this video, I will be talking about negating compound statements. So let's get started. Okay, so negating compound statements. I'm gonna let you make some predictions. So once I show you the statements here, there will be four of them, and that will make two pairs of equivalent statements. Okay, so make your best guess and fill in the blank. Statement one, that's the negation of P and Q. Statement two is not P and not Q. Statement three is the negation of P or Q. And statement four is not P or not Q. All right, so pause the video, write down what you think are the equivalent statements are. So there's two pairs, write that down, and then proceed. All right, so let's test your predictions, okay? And how we're gonna do that is we are going to create a truth table. And as you know from the previous video, that an equivalent statement is when the truth values are true for all possible combinations, right? So here we have P and Q. So I'm gonna go ahead and take a look at P and Q, and then I'm gonna take the negation of that. It's just logical to do that because that's the order of connectives, right? And then I'm gonna take a look at P or Q, and then I'm gonna take the negation of that. And then the next thing I'm gonna do is I'm gonna negate P, negate Q, and then I'm gonna take the combinations of those, as in the and statement and the or statement. And let's just note what was on the previous screen. That was number one. That's number three. The yellow one is number two, and then the green highlighted one is number four. All right, so two statements P and Q, so you have four combinations. So here they are, true, true. And if that's the case, true, false. And then we have false, true. And then you have false, false. All right, if true and true, the statement is true. True and false, the statement is false. But then we would see now that the negation of true is false, and then the negation of false is true. And then the next one, false and true, that would be false. And then the negation of that would be true. And then false and false is false. Then the negation of that would be true. Okay, so that's number one. That's the truth value for number one. Now let's look at the or statement. Remember, the or statement is true as long as one of them is true, right? So it's either or both. So we have true. When we negate that, that would be false. True here, and when we negate that, that would be false. True here, and negate that, that would be false. And then false here, to negate that, that would be true. So we can see now that 1 and 3 are not equivalent, okay? Now, the negation of P would just be the opposite truth value of P. So here we go, that would be false, false, true, and true. Then the negation of Q would be the opposite of the second column. And that would be false, true, false, true. And then the next thing I'm going to look at is the combination of those negations. Okay, so not P and not Q. Okay, that's false, false. That is false. False, true. The end statement is false. True, false. So the end statement is false. And then true, true. The end statement is true. Okay, and then now let's look at or. Okay, so here it's or. False or false is false. False or true is true. True or false is true. And then true or true is true. So as we can see here, let's compare the truth values of all of those combinations. You can see that number 1 is equivalent to number 4, and then number 2 is equivalent to number 3. So we would say the negation of P and Q is not P or not Q. And that the negation of P or Q is not P and not Q. Okay, so negation of N is or, then the negation of or is N, and then you negate each one of those separately. And that's how I remember that. All right. Now, for example, if I say, I'll eat hamburger steak and mac salad for dinner, okay? This compound statement has the form P and Q, where P is, I will eat hamburger steak for dinner, and Q is, I'll eat mac salad for dinner, right? So my question to you is, what would it take for this statement to be false? Well, remember that the negation of P and Q, which is what I'm asking you, what would it take for this statement to be false? It would take this, not P or not Q, right? Now, since this is an or statement, then we would take either not P, which is I didn't eat hamburger steak, not Q, right? So this is okay. That will make it false. Or I could have not Q, which is I had no mac salad for dinner. Or both not P and not Q. That means I didn't eat hamburger steak and I didn't eat mac salad either. Okay, so what does it take for that statement to be false? You have 3 scenarios there that could happen, right? And so what we want to remember is the negation of and is or, and then you negate each one of those simple statements. Now, if we had it the other way around, if I say, I'll catch a ride home or take the bus. So this is of the form P or Q. P is I'll catch a ride home, and Q is I'll take the bus. Okay, so what would it take for this statement to be false? Well, from the investigation that we just did, we realized that the negation of P or Q is not P and not Q. And here we have the connective and, right? And means both of those have to satisfy. That means both not Q and not P. So what would it take for this statement to be false? This original statement here. Okay, in order for that original statement to be false, I would have not caught the bus home, and I would not have caught a ride home either. Okay, so to answer this question, we would say in order for the original statement to be false, I would have to do both not P and not Q. All right, so what's the negation of if P then Q. Let's remind ourselves of the truth table for if P, then Q. So we have true, 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 false, right? True and true, if true, then true, then the statement is true. If true, then false, then the statement is false. If false, then true, then the statement is true. If false, then false, then the statement is true. So if we notice here that the only time that the if-then statement is false is the if part, meaning P is true, but Q is false. So if I make a statement like this, if I say, I'll cook pasta, if I cook pasta, then I'll bake cookies. Okay? If I cook pasta, then I will bake cookies. That's an if-then statement, right? That's of the form if P, then Q. What would it take for this statement to be false? Well, from here, P is I'll cook pasta, and Q is I will bake cookies. From the truth table, then, I would say that in order for this statement to be false, I would have done P and not Q. That means I did cook pasta, but did not bake cookies. That will make this statement false. Okay, so what is the negation then, to summarize that? The negation of an if-then statement is P and not Q. The negation of if P, then Q is P and not Q because of that right there. Okay, so let's practice a little bit more complicated statement there. If P, then Q and not R. Okay, so what's the negation of that? Well, before we do that, we would think about the order of connectives, and we would realize that the second part right there, the then part, is really a compound statement, right? Q and not R. All right, so remember now that the negation of if then is P and not Q. So the negation of this statement that we're looking at, here's the first part, here's the second part, right? To negate that, I would have to think P and not Q. The Q here really is this whole chunk right here. So it would be not that, okay? And then this right here, the negation of an and statement is an or statement. So that will turn out to be not Q or R. And that is how that works. Okay, that's it for today.